Good day, class. For today, our topic is carbon compounds, and to be more specific, we're going to talk about different organic compounds. Here are the learning objectives. First, recognize the different classes of organic compounds. Second, identify the different functional groups of organic compounds. Third, differentiate the four formulas used in organic compounds: the molecular, condensed structural, forced structural, and the line formulas. And lastly, draw the full condensed structural and line formulas of the given compounds. And let's start the discussion. From our previous discussion, you've learned the difference between organic and inorganic compounds. Now, to recall the concept again, organic compounds are compounds that contain carbon that is covalently bonded to non-metals. And you've learned a lot of things about organic compounds that makes it different from your inorganic compounds. And in order for us to have deeper understanding about this particular compound, the branch of chemistry that will help us to get wider information about it is your organic chemistry. Organic chemistry is the study of carbon and carbon compounds. And other than this will give you concepts regarding structure, properties, composition, reactions, and preparation of carbon-containing compounds. Now, class, there are plenty of organic compounds. And in this discussion, we are going to learn the different organic compounds. And also, we are to differentiate one organic compound to another organic compound based on its structure. Ibig sabihin lang nun, sa sobrang dami ng organic compounds, how can we categorize them? How can we classify them? So this discussion will really help us to learn those organic compounds, how they differ in terms of structure to another organic compounds. Let's start our discussion with the simplest class of organic compound, that is your hydrocarbons. So as mentioned, hydrocarbons are the simplest class of organic compounds that are made up of carbon and hydrogen. So these two elements are the main elemental composition of your hydrocarbons, only carbon and hydrogen. And your hydrocarbons can be further classified or subdivided into two. It could be saturated or unsaturated. And for your saturated, there is only one kind of hydrocarbon, and that is alkane. While for your unsaturated hydrocarbon, there are two. These are your alkene and alkyne. Okay, so this is your alkene and your alkyne. So when we say saturated hydrocarbon, the bond that you can observe here is only single. Okay, there is single bond observed to the structure of your alkane. Okay, so carbon to carbon and hydrogen attached to your carbon, the bond is single, that is alkane. If you would see double, triple bonds in the structure of your hydrocarbon, okay, for your carbon to carbon double bond, that is now your alkene. Okay, so double bond. Now for alkane, single bond. Now if there is triple bonds that you observed to your carbon to carbon, okay, so that is now your alkyne. So triple bond is observed. So again, the only saturated hydrocarbon is your alkane. Your alkane contains single bond. Now your unsaturated, it could be alkene and alkyne. Your alkenes are hydrocarbons that have one or more carbon-to-carbon double bonds in their structure, while your your alkynes contain a minimum of one carbon-to-carbon triple bond. Okay, so again, saturated, single bond. Unsaturated can be double or triple bonds. Now, also, you can see hydrocarbons that are classified as aliphatic or aromatic. Okay, so your aliphatic hydrocarbons are your alkane. This is alkane because it has single bond to your carbon to carbon. So this is your alkane. Example is your ethane. This is your alkene because it has two double bonds to your carbon to carbon atom, and this is now your alkyne. Okay, triple bond is observed here. So aliphatic and aromatic are two subcategories of your hydrocarbons aside from being saturated and unsaturated. What makes them different is that your aliphatic do not have rings. Okay, instead they form chains of carbon and hydrogen. So your aromatic, on the other hand, okay, have rings, which will contain single, this one, and double bonds. So example is your benzene ring. So this is your benzene ring, which are cyclic. So the chain is cyclic chain with 6 carbon. 1, 2, 3, 4, 5, 6. That form hexagon, as you've noticed on its shape. Aliphatic chain, the structure is arranged in chain manner, while your aromatic forms a ring-like structure, okay, as presented in this example. Okay, so these are your aliphatic and aromatic hydrocarbons. Now let's talk about each of your aliphatic hydrocarbons, the alkane, alkene, and alkyne, what makes it further different from each other. Yun yung pagbibigyan natin ng focus class. Now, let's have again alkanes. Now, as mentioned earlier, your alkanes are hydrocarbons that have only single bond. Kaya nakategorize yan under saturated hydrocarbon because it has only single bond in whatever carbon to carbon interaction, okay, in its structure. Also, your alkanes follow the general formula C sub N H sub 2N plus 2. Now, the N here is the value of, or the number of your carbon atoms observed in the given alkane, okay, or the given organic compound, specifically your alkane. So let's say the value of N is 4. And if we're going to use this general formula, we just simply substitute the value of 4 to the N. So that becomes C sub 4, H sub 2 times 4 plus 2. So we just simply we need to simplify this one, making it C sub 4, H sub 2 times 4 is 8 plus 2 is 10. So this is now the molecular formula of a certain alkane. Okay, again, this is a molecular formula. So that makes it this means that you really follow how to use this formula for alkane. And the name of this compound ends with A and E. A and E is the suffix. So whatever alkane na ma-observe mo or makita mo, so what makes them common is that they have this suffix A and E. Example, propane, Okay, propane, methane, so on and so forth. So this is under your alkane. Okay, if you have or you're given is only the name of the organic compound, so you will classify it as an alkane. Okay, or if you have the structure, you have to simply look on its if it contains single bond. Okay, yun yung sinasabi kanina ni Sir, making it saturated. So the use of your alkanes, they are generally important raw materials of the chemical industry and the principal constituent of gasoline and lubricating oils. So common naman na din sa atin yung butane. Butane is an alkane and that is commonly used para sa pagluluto because you need fire, right? So that is an alkane. This is the structure that I'm talking earlier. So if you observe this kind of arrangement, tinatawag natin to in general as functional group. Okay, this is the functional group of your alkane. Whatever alkane you may observe, common sa kanila ay they have single bond between your carbon and another carbon atom. Okay, so that's how you will categorize a particular organic compound. So aside from looking to its name ending with A and E, so this is a good way to differentiate it from another organic compound. Now moving on, we have alkenes. This is still hydrocarbons but under na siya ng unsaturated. So what makes it different is that double bond. No? Double bond ang ma-observe natin. And it follows this general formula C sub N, H sub 2N. So let's say we have N is equal to 4. Substitute pa rin natin yung class. We have C sub 4, H sub 2 times 4. We have C sub 4, H sub 8. This is now again the molecular formula of a certain alkene. And also, the name of this compound ends with E and E. So, as compared to your alkane, it ends with A and E. Now, for your alkene, E and E. So, examples of these are your propene, pentene. Those are examples of your alkenes. So, by merely looking to the name, the suffix of it, you can actually categorize it under alkene. Okay? So, alkanes are used in the synthesis of alcohols, plastics, lacquers, detergents, and especially for ripening of fruits and fuels as starting materials. For ripening of fruits, yung common na naririnig nyo or na-observe nyo sa parents nyo that if you have unripe fruit, di ba, you have to put that near a banana kasi banana releases not just banana but there are also other plants that releases ethylene. Ethylene, looking to its suffix, alkene yan, and it helps to ripen fruit because ethylene is a gas that actually gas produced by plants that known to be ripening hormone that stimulates fruit ripening. Yun yung trabaho ni ethylene. Okay, so this is the functional group of your alkenes. Whatever alkenes you have in terms of its structure, you will always observe that one or more of its carbon atoms merong double bond. Okay, may double bond. Now for alkynes, so this is another unsaturated, okay, hydrocarbon. So they're triple bonds na ma-observe natin between carbon atoms, one or more triple bonds between your carbon atoms, and it follows this general formula. Ganun pa rin ang strategy. So in finding its molecular formula, substitute lang the value of N, and N is the number of atoms, carbon atoms to be exact. Now let's say N is equal to 4 again. So we have C sub 4, H sub 2 multiplied to 4 minus 2. You have C sub 4, H sub 2 times 4 is 8 minus 2 is 6. Okay? So this is the molecular formula of a certain alkene. Kanina, for your alkane, you have C sub 4, H sub 10. This is for your alkane. And for your alkene, C sub 4, H sub 8 for your alkene. Now you observe for your alkyne, it is C sub 4, H sub 6. What makes them differ in terms of its molecular formula, there is a decrease in the number of atoms for your hydrogen. How many? Dalawa. Right? So that's another technique that you can actually use, class, for writing the molecular formula of alkene alkyne. As long as you have the molecular formula of your alkane, you just simply deduct 2 to it. Okay? For your alkene. Okay? Now, 4 naman ang i-deduct mo sa alkane para makuha mo yung formula, molecular formula for your alkyne. Okay? Hopefully, you follow that one. Now, the name of this compound ends with Y and E. So, example of these are, you would see a heptine. Okay? What else? Pentine, so on and so forth. So if you have the given, if your given is the name, you look to the suffix, you can classify this compound as alkane. Okay, but if you have structure, okay, you will use this functional group. Ulitin natin, functional group is common to whatever compounds na pinag-uusapan natin. Let's say alkynes. This is observable to alkynes in terms of its structure. There is one or more, or it contain one or more triple bonds between carbon atoms. So, pag may tatlong bonds, that's the time that you categorize it as alkyne. Okay? And alkynes are helpful to weld hard materials, useful organic solvents, and is starting material for polymers. Okay, so we have alkynes. Alkanes, alkenes, alkynes are part of your hydrocarbon family. So hydrocarbon family is the simplest kind of your organic compounds. Let's move on to haloalkanes. So this is another class of organic compounds. Okay. Now, haloalkanes are a group of chemical compounds comprised of an alkane with one or more hydrogens replaced by a halogen atom. Now, your halogen atom or halogens in particular are any elements found in your periodic table, specifically in group number 17. These are your bromine, iodine, chlorine, so on and so forth. So, one or more hydrogens attached to your carbon is being replaced by a certain halogen. It could be your bromine, iodine, chlorine, so on and so forth. So, haloalkanes follow the general formula C sub N, H sub 2n plus 1, and there is X, and X is any halogen. Okay, so that is halogen atom. It could be bromine, iodine, chlorine. Okay, now, so if you're going to get the molecular formula of a certain haloalkanes, you do the same procedure na ginawa natin kanina when we have hydrocarbon family. Okay? So, ganun lang din yan. Substitute the value of N to this and identify the halogen that is attached to this particular haloalkane. Okay? Now, haloalkanes are used as flame retardants, fire extinguishants, refrigerants, propellants, solvents, and for your pharmaceuticals. Okay? Common haloalkanes na we can or I can provide to you as an example is your chlorofluorocarbons. I know this is not new to everyone. Most of your haloalkanes are pollutants. Okay, most of them are pollutants, like what I mentioned earlier, chlorofluorocarbons, and that is known to be the reason why ozone is depleting. Okay, your again example is your chlorofluorocarbons. So an example of your haloalkanes that are known to be a pollutant, that is the reason why, or a factor, or a compound that depletes our ozone layer. So for its functional group, so this is the typical structure. The R here is the alkane. So one or more hydrogens are replaced by an X. As mentioned earlier, that is your halogen. So this is the functional group, and one way for us to identify if the given organic compound in terms of its structure is an haloalkane. Ito yung tatandaan natin, guys. Okay? Moving on, another class of organic compound is your alcohols. So alcohol is an organic compound with a hydroxyl OH, that is we have to call it as hydroxyl, your OH, functional group on an aliphatic carbon atom. Aliphatic branch yan. Okay? The name of this compound ends with OL. So example niyan, given name could be propanol, butanol. Okay, if you would see a name that ends or with the suffix OL, you can classify it as alcohol. Okay, so the alcohols follow the general formula C sub N H sub 2 N plus 2, and there's O. Okay, so you know the technique. Follow the procedure that I taught you earlier. So N is any value, and that refers to the number of carbons. Okay, so they are highly flammable, making them useful as fuels, your alcohols. So they are also used in alcoholic drinks. That's the common thing that you know when we talk about alcohols, as well as solvents in maker pens, medicines, and cosmetics such as deodorants and perfumes. So the word alcohol in alcoholic drinks refers to your ethanol. Okay, that is another example of your alcohol. Ethanol, if you are actually talking about alcoholic drinks, the type of alcohol added to that is your ethanol. Okay, your ethanol. So, but your ethanol is also used as component of your alcohols, yung rubbing alcohol, so on and so forth. Now, this is the functional group of your alcohol. So the hydroxyl is attached to your alkane. Okay, your hydroxyl group is attached to your alkane. So that is another way to differentiate it from the rest of the organic compounds that I mentioned earlier. Now, moving on to another class of organic compound is your aldehydes. Aldehydes are formed when an oxygen atom is double bonded to the carbon atom at the end of the chain. Okay, the name of this compound ends with Al. So, example of it are propanal, okay, butanal. So, if you would see an organic compound ending with Al, that's the time that you will classify it as aldehydes. And the general formula it follows, your aldehydes is the C sub N, H sub 2, and O. Okay, so similar procedure in order for you to get the molecular formula of aldehydes. And aldehydes are useful, or they are important intermediates for the manufacture of resins, plasticizers, solvents, and dyes. They are used in your textile, food, rubber, plastics, leather, chemical, and healthcare industries. Actually, class, common example ng aldehydes na ginagamit in medicine, okay, is your formaldehyde, or commonly known as your formalin. Okay, so it helps to preserve specimens in the laboratory, your formaldehyde. So this is the functional group of your aldehydes that makes it different from the rest of the organic compounds or classes of organic compounds that I mentioned earlier. So this your oxygen atom is double bonded to your carbon here, and this oxygen that double bonded to your carbon is found at the end of the chain. Yan yung tatandaan natin. So this could be the R again is an alkane, or the R here is the given chain. So at the end of that chain is a double bond O. Okay, that's aldehydes. Let's have ketones. A ketone is a compound containing a carbonyl functional group bridging two groups of atoms. The name of this compound ends with O and E. So examples are, for your ketones, are your butanone, what else? Heptone. So if you would see an organic compounds having these particular names or ending with O and E, that's the time that you will consider it as part of ketones. Okay? So ketones follow the general formula C sub N, H sub 2, and O. So this is one way for you to identify their what they call that molecular formula. Okay? So ketones are most widely used as solvents, especially in industries manufacturing explosives, lacquers, paints, and textiles. Also, they are used in tanning as preservatives and in hydraulic fluids. Actually, your ketones, if you're going to look on its molecular general formula for you to identify its molecular formula, they are the same with your aldehydes. Okay, so they have, other than this, they have same functional group as aldehydes, but if you will look at this functional group, the C double bond O occurs somewhere along the chain, okay, rather than on the end of the carbon chain. If you're going to analyze the functional group, your aldehydes, the C double bond O is found at the end of the chain, but for your ketones, along the chain, okay, somewhere along the chain. So that's how you will remember the functional group of this organic compound. Next is your carboxylic acid. This is a class of organic compounds in which a carbon atom is bonded to an oxygen atom by a double bond and to a hydroxyl group, OH, by a single bond. So the name of this compound ends with OIC acid. So examples are your propanoic acid. Okay, what else pa ba? Your butanoic acid. So same procedure. If you would see this OIC acid as part of the name of the organic compound, that's the time that you will categorize it as carboxylic acid. Okay, so carboxylic acids follow the general formula C sub N, H sub 2, and O sub 2 for you to get the molecular formula of a certain carboxylic acid, as long as you know the number of carbon or the value of N. Carboxylic acids and Their derivatives are used in production of polymers, biopolymers, coatings, adhesives, and pharmaceutical drugs. They also can be used as solvents, food additives, antimicrobials, and flavorings. And your carboxylic acids are known to be your organic acids. Okay? They are known to be organic acids. Your carboxylic acids. So these carboxylic acids are compounds occurring naturally in different stages of our life cycles. It could be in your in our Krebs cycle, fermentation processes, no, and other geological processes. And your carboxylic acids are also present in your citrus fruits, okay, as they are natural food components, your carboxylic acids. So for the functional group, you would see that there is a double bond O, okay, bonded to your carbon is bonded to your oxygen. There is double bond here and an hydroxyl groups, okay, in this given molecule. So that's how you will categorize a certain structure if that is a carboxylic acid. Moving on is our esters. Any of a class of organic compounds that react with water to produce alcohols and organic or inorganic acids, that is your esters. The name of this compound ends with OATE. Esters are made by reacting carboxylic acid with an alcohol. Okay, when there's a reaction between carboxylic acid and alcohol, it produces ester and water. So that process is known to be, or the reaction is known to be esterification. So again, esterification is the reaction for you to produce esters by allowing carboxylic acids and alcohol to react. Okay? Example of your ester is your ethanoate. You would see OAT as suffix, that is an ester. Okay? And for the general formula, it follows this: C sub N, H sub 2, and O sub 2. Okay? And the main use of esters is for flavorings and perfumes. However, they can also be used in the chemical industry as solvents. Now, for functional group, so you would see here that there's a double bond O in your carbon atom, and O is found here and there between molecules R sub 1 and R sub 2. So if you would see this one, that is an ester in terms of its structure. Let's have amides. Any member of either of two classes of nitrogen-containing compounds related to ammonia and amines are known to be your amides. The name of this compound ends with amide. So examples are hexanamide, what else? Propanamide. So same procedure, if you would see a suffix amide, that compound is considered to be under amides. Okay? Now amides follow the general formula C sub N, H sub 2, N plus 1, and O. And your amides may be used to form resilient structural materials and organic solvent. Amides are found in many drugs. Now for its functional group, for the structure of a certain amides, you would see this particular arrangement or structure. So there's a carbonyl. This is a carbonyl. and an amino in the attached to your carbon atom here. So if you would see this kind of arrangement or structure, that's the time that you would classify it as under amides. Now, for the last, which is your amines. Amines are any member of a family of nitrogen-containing organic compounds that is derived either in principle or in practice from your ammonia, your NH sub 3. The name of this compound ends with amine. Okay? So example of this compound is your diethyl amine. So you see here a suffix amine, so that is really under amine. And amines follow the general formula C sub n, H sub 2, n plus 3, n. And they are widely used in developing chemicals for crop protection, medication, and water purification. And this is the functional group of your amines. So I give a certain molecule, and this is an amino. Okay, an amino group. So attached to a certain molecule, so that is your amines. Now, in the coming slides, you are going to use the things that you've learned from the different classes of organic compounds, and we're going to identify based on the structure if that is a alkanes, alkynes, so on and so forth. Okay, now let's have an example number 1, and we'll be using this table in order for you to easily identify the functional group of the given structure here. Okay, so we're going to identify the functional group of this structure. So having this structure, you would see an alkane here, single bond, but there is a certain element attached to your carbon, which is this found here, and that bromine is the element attached to your carbon, and bromine is a halogen. Okay, and therefore, if bromine is an halogen, this is now a haloalkane. Follow? So that's how you will categorize a certain structure, whether that structure belongs to a certain class of organic compounds. Okay? Now let's have another example. Using the same table again for us to easily determine the functional group of this structure. And you would see here a double bond O attached to your carbon. But you would see also another OH hydroxyl attached to your carbon. And if we're going to look on this table, that is a carboxylic acid, right? So hopefully you're following that one. Okay, now let's have another example. So we have this structure, and if you're going to observe, there's no attachments similar with the first two previous examples, like the carbonyl and the hydroxyl and the halogen. So therefore, it shows single bond between carbon atoms. This is now an alkane. Hopefully you're following that one. Okay, now let's have the fourth example. So having this structure, very evident that there is a double bond found in these two carbons, between these two carbons. So other than that, there's no anything that we can observe, right? So this is an alkene. The functional group on this in this organic compound is alkene, an alkene. Now, fifth example. So we have this structure. So what makes it different from the rest is that there is a double bond O here, right, at the end of the chain to your carbon atom here. So therefore, if you're going to recall our discussion, that is aldehyde, right? So this is an part of aldehyde. That becomes only ketones if the double bond O is found uh, between this C and C. Okay? So hopefully you're following that one. Always remember aldehydes, the double bond O is found at the end of the chain. Okay? And last example, hopefully you're following the entire procedures on how we can identify and determine the functional group. So let's have this one. So nothing is if you're going to see, there is OH, right, attached to your carbon here. Okay, so that's whether even if you can see this carbon here, the point of intersection of lines here is represented. It represents your carbon atom. Okay, remember your carbon atom shows 4 bonds. Okay, attachments to your carbon atom could be 4. Okay, so remember our previous discussion regarding that one. So OH, this is a hydroxyl group attached to your carbon. So that is alcohol. Okay, so hopefully you follow that one. Now let's talk about the 4 types of organic formula being used in organic chemistry or in your different classes of organic compounds. These are your molecular formulas, structural formulas, or full structural formulas, or expanded structural formula, if as being called by other reference materials, condensed structural formula, and the line diagram or the line formulas. Now, your molecular formulas, you would see from the given example that it shows or it describes, the molecular formulas describe the precise number and kind of atoms contained in this compound, right? And also remember that in your molecular formula, the constituent elements are represented by their chemical symbol, like with your carbon and hydrogen. And also the quantity of atoms of each element present in each molecule is shown as a subscript. Okay? So following by the given element symbol. Like with your carbon, there are 5 atoms, and for your hydrogen, there are 12. So that is your molecular formula. And how you will get the molecular formula of a certain organic compound, I already provided that earlier in my discussion, from your alkane up to your amides. The general formula, you will use that as long as you have the number of carbons given, you can do writing the molecular formulas. Now for your for your full structural formula or expanded structural formula, what makes it different to your molecular formula is that your expanded or full structural formula shows, okay, all the bonds connected to all of the atoms within the compound. So you would see that this is an alkane because the bond is just single, right? And the elements here are just carbon and hydrogen. Okay, so hopefully you're following that one. That is for your full and expanded structural formula. While for your condensed structural formula, you would see that it becomes the simplest version of your full or expanded structural formula. Now, for this particular formula, it shows all the atoms but omits some or all the vertical and horizontal bonds that you observe from your full or expanded structural formula. Okay, thus making it easier to write in a single line. Okay, so your condensed structure formula must be written in a single line or a single chain. Okay, not like this with your full or expanded structural formula. Now, for your line diagram, you represent it through lines like this one. Now, here class, each end of your line segment, which is this, it represents your carbon. This one, and this one. And it assumed to satisfy each carbon's octet rule. Okay? So that's how you represent it through line formula or line diagram. Now going back, this is just the same actually. Same alkane. Why? The molecular formula is C sub 5, H sub 12. If we're going to count each of the elements here, that gives you 5 for carbon and 12 for hydrogen. Okay? So it shows the kind of bond present in this organic compound. Now for condensed structural formula, this is just the simplest version of your full or expanded formula. If you're going to count the carbon, that is just the same with the subscripts presented by the molecular formula. Now for your condensed, 1, 2, 3. It seems 3, but you see there is a parenthesis sign here indicating that here there are 3 carbons inside this parenthesis, right? Distributive property. So there's no subscript for the carbon present here. That means 1. 1 times 3 is 3. 4 and 5, making it still 5. Now, if you're going to write it na gusto nyo ipakita talaga na 5, this is just another way to write it in condensed structural formula. It could be like this, CH3. That came from this one. So C, 1, 2, 3, CH3. Okay. A horizontal line that connects to the next carbon kasi single bond. Pag double bond yan, class, in whatever part of the carbon here, whatever part of the structure, kung pangatlo, pangalawang carbon yung nag-shows ng double or triple bond, you have to write double or triple bond. Okay, now for in this case, single lang naman, CH2. Dalawa lang yung hydrogen. Next, third carbon, CH. How many H? 2. So next, fourth carbon, how many? Pa rin. Now for the third one, tatlo na. Okay, so 1, 2, 3. Hopefully you're following that one. So this is another version of your condensed structural formula, and it contains the same exact number of subscripts for each of your element here. Okay, hopefully you're following that one. So it shows, no, we follow pa rin yung rule of your carbon, making it a unique atom. So there's 4 bonds in one carbon atom. So it really shows octet rule pa rin. Okay, it satisfies octet rule. So from this condensed structural formula, bakit po this is the line diagram of this alkane? Simply because we're counting here the 5 carbons. Okay, so 1, 2, 3, 4, 5. So no need for you to write here the hydrogen and the carbon element symbol. So that is being represented by line. Okay, now if that is 6, so you have to 1, 2, 3, 4, 5, 6. This is now the new line diagram. If carbon is 6, the number of carbon is 6. So hopefully you're following that one. Now I have examples here para we can further intensify our understanding regarding this matter para mas madali sa ating lahat. Now let's have example number 1. Ethanol, given the molecular formula. So in this case, we're going to write the full structural formula, the condensed structural formula, and the line formula. Okay, there are three things that we have to do in each of the examples. So ethanol, it has this molecular formula C sub 2 H sub 6 O. Okay, so if there's no molecular formula given, okay, and if you need to get the molecular formula, lagi naman given yung number of carbon. Okay, so you just simply use the general formula provided in my discussions earlier. Now, in this case, for the full structural formula, so that means full structural formula. So there are two carbon. You begin with writing carbon, the symbol, and there are two. How many hydrogens? 6. And since this is ethanol, that is alcohol, therefore there is an hydroxyl group attached to your carbon. Let's say we attach that hydroxyl group in this second carbon. You can also attach that in this carbon. Okay? Now, we have to distribute 6 hydrogens. We're done with oxygen. Na-distribute na natin siya. Isa lang. So, 5 na lang kasi there is H here being, we actually, that is part of your hydroxyl group. Okay, now, and ethanol, okay, alcohol doesn't show double bonds or triple bonds. So, we connect it with a horizontal line to your other carbon. So, satisfying octet rule. So, there are 4. No, for the first carbon here, lines. So, that is for first hydrogen, second hydrogen, third hydrogen. So, 1, 2, 3, 4. There are 4 na. Now, it shows here that on the second carbon, dalawa lang ang lines. So, hindi pa rin na-satisfy ang octet rule for carbon here. We have to add 1, 2. Diba? Hanggang 4 ang bond sa carbon atom. So, that's the time that we will put hydrogen here and another hydrogen. 1, 2, 3, 4, 5, 6. So, 6, 1, 2, 2, and 1 oxygen. So, this is the full structural formula of your ethanol. Now, for the condensed structural formula, we're going to simplify it without writing the vertical or the other horizontal lines. Okay? So, let's focus first on the first carbon. How many hydrogens? 3. CH sub 3. And let's copy the horizontal line here, indicating the bond between one carbon and another carbon. So how many hydrogens here? 2, CH sub 2, and OH. So this is the condensed structural formula. How many carbons? 2. 1, 2. How many hydrogens? 3 plus 2, 5 plus 1, 6. How many oxygen? Only 1. Okay, we still satisfy the molecular formula. Line formula. Okay, so each end of the line segment is your carbon atom. So this one, another one, and this is the first carbon, the second carbon, and there's an attachment of OH. So you need to write OH to really indicate that the line formula is for your alcohol organic compound. Okay? So hopefully you're following that first example. Moving on to the next example, para mas mapalalim pa natin, and we keep on practicing this. Let's have heptane. The suffix ends with A and E. This is an alkane. Okay? So, dapat alam mo munang i-classify that one. And the molecular formula is already provided. So, let's start with the full structural formula. So, how many carbons? 7. That's the first thing that we have to write. 1, 2, 3, 4, 5, 6, 7. So, there are 16 hydrogen atoms that we have to distribute in this carbon. So, satisfying the rule of alkane single bond between your carbon atoms. So, for the first carbon, satisfying pa rin the octet rule. So, tatlo yan dito. Bakit po? 4 bonds, 1, 2, 3, 4. Right? So, here, 1, 2, there are 2 na lang na hydrogens that we have to attach here. Octet rule pa rin, 1, 2, 3, 4. Right? So with this, 1, 2, 3, 4. With this 1, 1, 2, 3, 4, 1, 2, 3, 4, and this one. And for the last, 1, 2, 3, 4. Let's count the hydrogen atoms kung tama yung bilang. It should be 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And this is alkane single bond blank. So that is the full structural formula. For the condensed structural formula, we have to begin with the first carbon. How many hydrogens? Tatlo. Copy the bond for the alkane, single. Second tayo, CH2. 1, 2. Third, CH2. Okay, fourth carbon, CH2. Fifth, CH2. Sixth, CH2. And 7, CH3. Okay, so if you're going to add all of the subscripts for the hydrogen, that gives you pa rin 16. Okay, so hopefully you're following that one. And for the last line formula, each ends of your line segment, represent your carbon. Yun naman yun. So 1, 2, 3, 4, 5, 6, 7. 7, no? So 1, 2, 3, 4, 5, 6, 7. So this is the line formula. We don't need to put OH or whatever attachment here because this is an alkane. Okay? So hopefully you're following that one. Now, pag may double bond, okay, kung pangalawang carbon yung may double bond, you have to put another line here to represent that this is another kind of organic compound. Moving on to the next example, let's have hexene. So we have hexene here, having this molecular formula C sub 6, H sub 12. So let's draw the full structural formula. So this is the name of the compound ends with E and E. So that means this is an alkene, right? And what is this 3 dash serve? So the 3 here indicates where or the place where you could see the double bond. So this is double bond. On the third carbon, there is double bond. Yan ha, para mas madaling masundan. So how many carbons? 6. 1, 2, 3, 4, 5, 6. On the third carbon, there is double bond. 1, 2, 3. You can also count here. 1, 2, 3. Parehas pa rin naman. Right? So be mindful about that one. So there are 12 hydrogens that we have to distribute, satisfying the octet rule for your carbon. So the rest is single bond na. Okay, so ilan dito? Isang H, an H here, an H. Octet rule, right? On the second carbon, dalawa kasi octet rule pa rin. On the third carbon, 1, 2, 3. So isa na lang ang pwedeng hydrogen dito. Kasi pag naglagay ka pa dito ng isang line and hydrogen, you're not satisfying the octet rule for your carbon. It should be 4 only. 1, 2, 3, 4. Okay? Hopefully you follow that one. On the fourth carbon, 1, 2, 3. So isa na lang din. Okay? To make it 4. Your carbon atom should only have 4 bonds hanggang 4 lang. Now here, 1, 2, 3, 4. Okay, dalawa na dito. And for the last, 1, 2, 3, 4. So this is now the full structural formula. Bilangin natin. 1, 2, 3, 4, 5, 6. Check tayo dito. Dapat 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Check din tayo. Okay, this is now the full structural formula. And for the condensed structural formula, we have, so condensed na, no? So first carbon, ilan? Tatlo. CH3, single bond to the next one? Dalawa. Okay? Single bond to the third carbon. Ilan? Isa. At may double bond. Okay? Now, for the fourth carbon, may isa lang din. Single bond. Ito yun. To the fifth. Dalawa. Right? And to the sixth carbon, merong tatlo. So, that is your condensed structural formula. Now, for the line formula, ganun pa rin ang rule natin. 1, 2, 3, 4, 5, 6. So, 1, 2, 3, 4, 5, 6. Okay? So, 1, 2, 3, 4, 5, 6. Saan yung double bond? Makikita, third carbon. 1, 2, 3. So, dito yung double bond. Okay? Follow? So, that's what I'm telling earlier. Let's have the fourth example, which is 2-pentyne. Okay? So, the molecular formula is C sub 5H sub 8. So, YNE, suffix YNE indicates that this is an alkyne. Okay? So, 2, meaning, same with your alkene earlier, that is where the triple bond is located. Okay, on the second carbon. So, let's draw the full structural formula or the expanded structural formula. So, we have 5 carbons here. 1, 2, 3, 4, 5. Where is the triple bond? On the second carbon. 1, 2. It could be in this, or you can draw here on the second. Okay, pero dito tayo. 1, 2. So, triple bond. 1, 2, 3. Okay, hopefully you're following that one. Now, the rest is single bond. Right? For this case. Now, we have to consider again that each of the carbon atom satisfy your octet rule. So, for the first one, we have 3 hydrogens here. Okay? So, for the second, do we still need to write or put hydrogen here? No na, kasi 1, 2, 3, 4. Okay, on the third carbon, do we still need to put an hydrogen atom here? A hydrogen atom here? No na din, kasi 1, 2, 3, 4. So, moving to the fourth one, 1, 2, 3, 4. Okay? Now, for the last, 1, 2, 3, 4. Okay, so let's count the hydrogen atoms. 1, 2, 3, 4, 5, 6, 7, 8. So, check. 1, 2, 3, 4, 5. Check. Okay, second carbon, check din tayo dyan. Now, condensed structural formula. So, simplify lang natin to. CH sub 3, tatlo kasi. Single bond. C, walang hydrogen. Triple bond. C, single pa rin. CH2, dalawa. And CH sub 3. So, this is the condensed structural formula. And now, for the line formula, same rule. 1, 2. Okay. 3, 4, 5. So, where is the triple bond? On the second carbon. 1, 2. So, we will put 2 lines here para triple bond. 1, 2, 3. So, 1, 2, 3, 4, 5. This is the line formula for your 2-pentyne. So, hopefully, nasusundan na natin. Let's have the fifth example, which is your propanal. Having this molecular formula C sub 3, H sub 6, O. So, from the suffix NL, that indicates that this is an aldehyde. Okay, so this is an aldehyde compound. So, full structural formula. So, we have 3 carbons. So, 1, 2, 3. And since this is aldehyde, following the rule that the double bond O is found at the end of the chain. It could be here on this carbon or here. Okay, as long as at the end of the chain. So I'll write the double bond O here and an H here, right? So satisfying the octet rule for this carbon. So apat yon, octet rule is there, oxygen is here. So we check na tayo sa oxygen, isa lang naman. So ilan na lang na hydrogen ang distribute? 5 kasi nga may isa na tayo dito, right? So it should be 4 bonds here. Okay, so and in this case, dalawa na lang, right? So 1, 2, 3, 4, 5, 6, check. 1, 2, 3, check. Oxygen is check. So that is your full structural formula for your propanol. So aldehyde yun. Lagi pa rin i-consider yung functional group ng whatever organic compound given before you proceed to the full structural formula. For the condensed structural formula, so simplify lang natin ito. So CH3 for the first carbon, second carbon single bond lang yon. CH2, third carbon single lang, tapos may double bond O and hydrogen. So this is the condensed structural formula for your propanol. Line formula, ganun pa rin naman. So 1, 2, 3, 1, 2, and 3. Okay? So in this case, on the third carbon, there is double bond O. Lalagay natin yon para from the line diagram, ma-indicate na aldehyde yan. And then an H here. Okay? Indicating that the double bond O is found on the end of the chain. Okay? So hopefully you're following that. Now, last example. We have hexanoic acid having this molecular formula C sub 6 H sub 12 O sub 2. So my oic acid, ito yung palatandaan natin. So this is a carboxylic acid. Okay, remembering its functional group, we can properly draw the full structural formula. Okay, so there are 6 carbon. 1, 2, 3, 4, 5, 6. Check tayo dyan. And then, this is carboxylic acid. So, at the end of the chain, may double bond O at my hydroxyl group. Right? So, ayan. That's how we write the functional group in this case. So does it follow the octet rule for the carbon atom? Yes. So 1, 2, 3, 4. Okay. Now the rest is single bond. Okay. So how many hydrogens do we have to distribute? 11 na lang minus this one. Okay. So how many oxygen? Dalawa. Check tayo. 1, 2. So for the first one, satisfying the octet rule, as well as this, and this. Let's count the number of hydrogens that we distributed na. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Check din tayo dyan. This is the full structural formula of your hexanoic acid, a carboxylic acid. Condensed structural formula, simplest version of this, but in chain manner, in a single chain manner. So CH sub 3 for the first carbon, single bond CH sub 2, 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 and the last C double bond OOH para represented pa rin si functional group of your carboxylic acid. Now for the line formula, so ganun pa rin naman, 1, ilan to? 6, 1, 2, 3, 4, 5, 6. Now at the end, there should be double bond O and OH para to indicate that this is a carboxylic acid. So how many carbons? 1, 2, 3, 4, 5, 6. 6 pa rin. So that's the discussion. Okay, hopefully you've learned something from this talk. So those are the different organic compounds, and this is how you will present a certain organic compound in terms of full structural formula, condensed structural formula, and line formula.